Hi children, in this video we are going to know about the prime factorization method of finding LCM and GCD of real numbers chapter. First, let us see the method of prime factorization. First, consider two numbers 18 and 21. For this, first we have to prime factorize the given numbers as below. You know that the prime numbers are 2, 3, 5, 7, 11 and so on. So first 18 can be factorized as 2 into 3 into 3. Whereas 21 is 3 into 7. Just here you observe as the prime factors for 8 does not consist 7, whereas 21 does not consist 2. So, here we are equating all primes in both numbers using the exponent identity a power 0 is equal to 1. So, for the first case, as 18 has 2 and 21 does not has 2, we put 2 power 0. Whereas in third one, 18 does not have 7, so we put 7 power 0. In order to easy calculating. First, the LCM, the product of highest exponents of each factors. That is 2 into 3 square into 7, which is 2 into 9 into 7. The answer is 126. Let's see, in the first row it is 2 is the maximum, and the second row 3 square is the maximum value, and third one 7 is the maximum. So product of these three. Now GCD, the product of lowest exponents of each factors. So we have to take the lowest exponents from each row. So first row it is 2 power 0. On second row 3 and third row 7 power 0, whose values are 2 power 0 and 7 power 0 is 1. So the GCD is 1 into 3 into 1, that is 3. So LCM and GCD of 18 and 21 is 126 and 3 respectively. Let us have some more examples for easy understanding. Okay. So, the first one is find LCM and GCD of 12, 15 and 21 in this method, in the prime factorization method. So, 12 can be factorized as 2 square into 3, whereas 15 is factorized as 3 into 5 and 21 is factorized as 3 into 7. So, for equating the factors, we put 5 power 0 and 7 power 0 in the 12th factors, 2 power 0 and 7 power 0 in the 15 and 2 power 0, 5 power 0 in 21. So, LCM is the highest powers, L2 square, 3, 5 and 7 multiplication, which gives 420. Observe. Here 3 is the maximum, 3 and third row 5 is the maximum, so it is 5 and fourth one, 7 is the maximum, so it is 7. Now GCD, the lowest powers, so 2 power 0 and 3, 5 power 0 and 7 power 0, whose product is 3. Here first row 2 power 0, first column, and the second column it is 3, and third column it is 5 power 0, and fourth column it is 7 power 0. So only 3 is there. So LCM and GCD of 12, 15, 21 is 420 and 3 respectively. Let us have second one. Find LCM and GCD of 8, 9, 25. 8 can be factorized as 2 cube and 9 can be factorized as 3 square and 25 is written as 5 square. So in order to equate all the factors in these three, we put like this. Now LCM is the maximum powers, that is 2 cube, 3 square and 5 square, whose value gives 1800. Let us see. Here 3 square and the last column it is 5 square is the maximum power. Now GCD we have to take lowest powers, 2 power 0, 3 power 0 and 5 power 0. Each value is 1, so GCD is 1. So LCM and GCD is, that's all. Next, coming to the third one, find LCM and GCD of 12, 18, 24 in this prime factorization method. So first 12 can be factorized as 2 square and 3, and 18 is factorized as 2 into 3 square, and 24 is factorized as 2 cube into 3. Here no need to equate the factors because all numbers consist of same number, same factors. So just by comparing, we can write LCM and GCD according to their rule. Now LCM is the product of highest powers of the factors of each number. So here 2 cube in the first column and 3 square in second column, whose value gives 72. Whereas GCD is the product of lowest powers of each factors of these numbers. That is, they said 2 is the least one in the first column and 3 is the least one, whose product is 6. So the LCM and GCD of 12, 18, 24 is 72 and 6 respectively. Is it clear? Now let us have last one, fourth one. Find LCM and GCD of 17, 23 and 29 in prime factorization method. Here you observe the numbers, those have a special property. 17 can be written as 1 into 7, 23 is 1 into 23 and 29 is factorized as 1 into 29 only, because these all numbers are, yes, prime numbers. So these, they have only two factors, 1 and itself. So LCM is product of all numbers, 1 and 17 and 23 and 29, whose value is 11,339. Whereas GCD is 1. So LCM and GCD of 17, 23 and 29 is 11,339 and 1. So here the important point is, for any two prime numbers PQ, LCM is product of the numbers itself, that is P into Q. Okay, now GCD is 1. This you have to remember. And next,